Hello students. In the last video we discussed continuity and today we are dealing with differentiability. Before that we need to recall some of the things we have learned last year in the chapter limits and derivatives. Hope you remember the formulas. So here is our first point, derivative of x raised to n, which is equal to n x raised to n minus 1. From that we can obtain derivative of x, that is 1. And we can find out derivative of any power of x like x square, x raised to 4, x raised to 100. Even we can find out negative powers like x raised to minus 4, x raised to minus 99, etc. The next point is derivative of log x, that is simply equal to 1 by x. The next is an important point, derivative of a constant, that is always 0. For example, pi, log 200, etc. are constants. Derivative of them will be 0. Here is the next point, derivative of k f of x, where k is a constant, so we can take that constant outside and we can rewrite it as k into d by dx of f of x. Look at the first example, 2x square, where 2 is a constant, so we can write it as 2 into derivative of x square. Now we need to remember derivatives of trigonometric functions also. D by dx of sin x is cos x, d by dx of cos x is minus sin x, d by dx of tan x is sec square x, d by dx of cot x is minus cosec square x, d by dx of sec x is sec x tan x, and d by dx of cosec x is minus cosec x cot x. Look at cos x, cot x and cosec x. They are starting with c and their derivatives carries a negative sign. You can keep this point in mind so that it will be easy to remember. Last year we have discussed two important rules. First one is product rule and the second is quotient rule. Now the product rule. Let v and u be any two functions. Derivative of v into u is simply equal to v u dash plus u v dash, that you can obtain in the box. Then quotient rule. According to quotient rule, derivative of u by v can be written as v u dash minus u v dash divided by v square. In this case, the connecting sign is negative here. So just be careful about the first term, that is always v u dash. Here is one thing we need to learn and that is chain rule. Consider f a composite real valued function. F can be written as f is equal to v of u, where the u is a function of x. Just put t is equal to u of x. Now the function can be written as f is equal to v of t. Now differentiate f with t and t with x. That is, we need to find out df by dt and dt by dx. Then we can simply write df by dx as df by dt into dt by dx. We can clearly understand the concept by the help of the given example. Given f is equal to sin x square, where u, the function of x, is x square. So put t is equal to x square. Now the function is f is equal to sin t. As we discussed, we need to find out df by dt and dt by dx. On differentiating f with respect to t, we will get cos t. On differentiating dt with respect to x, we will get 2x. So we can write df by dx as df by dt into dt by dx, that is cos t into 2x or 2x into cos t. We know the value of t, that is x square, so we can simply write it as 2x into cos x square. The theory we discussed is a bit difficult and time consuming. So here is a trick through which we can easily obtain the answer using chain rule. Again consider the last example we discussed, f of x is equal to sin x square. We need to obtain f dash of x. So first of all, we need to identify the function type. Here it is trigonometric function, so it is easy to figure out. Also function can be in the format x raised to n or log x. So the first thing we need to do is just identify the function type. As we said, here it is sin x square. We need to obtain f dash of x. To obtain f dash of x, consider that sin. If it was sin x, we know its derivative is cos x. So write cos and put brackets. And then write whatever given in the question as angle. So here it is x square, so write cos x square. Now we need to multiply it with the derivative of x square, that is 2x. So cos x square into 2x, or we can rewrite it as 2x into cos x square. In this way, we can easily identify the answer. Now look at the next example, d by dx of log 2x plus 4. This is a log type function. So just look at log x. If it was log x, we'll write the answer as 1 by x. Here it is not log x but log 2x plus 4. So we need to write 1 by 2x plus 4 into derivative of 2x plus 4, that is 2. So the answer is simply 1 by x plus 2. We'll get on solving like that. Now the next example, d by dx of x square plus 2 the whole raised to 5. This is of type x raised to n. So 5x square plus 2 the whole raised to 4 into, we need to multiply it with derivative of x square plus 2, and that is 2x. So the answer is simply 10x into x square plus 2 the whole raised to 4. Just remember this way, we can easily find out the answer. Here are some simple problems. The first one is derivative of 2x square plus 2x plus 2. In this case, we need to differentiate each of the terms, that is derivative of 2x square plus derivative of 2x plus derivative of 2. Now derivative of 2x square is 2 into d by dx of x square, that is simply 4x. Now derivative of 2x is 2 into d by dx of x, that is again 2. Now derivative of 2 is 0 because 2 is a constant. So the answer is 4x plus 2. Now the second question, d by dx of x square plus 5. Again we need to differentiate d by dx of x square and d by dx of 5. So on doing d by dx of x square, we will obtain the answer as 2x, and derivative of 5 is again 0 because 5 is a constant. So the answer is simply 2x. Now derivative of ax plus b, where a and b are constants, so the answer is again a. Now derivative of x square plus 3x, you can proceed in the way we have discussed. So the answer is 2x plus 3. Now x square plus 2 the whole square. This is similar with the case x raised to n. So the answer is 2 into x square plus 2 the whole raised to 1 into derivative of x square plus 2. On solving, we will get the answer as 4x into x square plus 2. So here are some problems based on trigonometric functions. The first one is tan 2x plus 3. As we have discussed, in case of tan x, the derivative is sec square x. So we can write it as sec square 2x plus 3 into derivative of 2x plus 3, that is 2. So the answer is 2 sec square 2x plus 3. Now the second question, sin x square plus 5. Here also cos x square plus 5 into derivative of x square plus 5, that is 2x. So the answer is simply 2x into cos x square plus 5. Now the third question is also similar to what we had discussed. Cos of sin x, which is equal to minus sin x into derivative of sin x. Derivative of sin x is cos x. So we can simply write the answer as minus sin x into cos x. Now the last one is here, d by dx of sin ax plus b. For sin it's cos, so cos ax plus b into derivative of ax plus b, that is a. So the answer is a cos ax plus b. Now look at these questions. You can pause the video and try to obtain the answers by yourself. Then we'll discuss. Look at the first question. Derivative of 2x plus 1 the whole cube. This is similar with the case x raised to n. So we can obtain the answer as 6 into 2x plus 1 the whole square. Now the second question, derivative of x cube plus 3x square plus 7. We need to differentiate each of the terms and we can obtain the answer as 3x square plus 6x. Now the third question, derivative of cos x square plus 2x. This is a trigonometric function. So if it was cos x, we can write it as minus sin x. So here it is cos x square plus 2x. So the answer is minus sin x square plus 2x into derivative of x square plus 2x, that is 2x plus 2. So we can write the answer as 2x plus 2 into minus sin x square plus 2x. On solving, we can write it as minus 2x plus 2 into sin x square plus 2x. Now the fourth question, d by dx of cosec 4x. In case of cosec x, the derivative is minus cosec x cot x. So here it is not x but 4x. So the answer is minus cosec 4x cot 4x into derivative of 4x, that is 4. So the answer is simply minus 4 cosec 4x into cot 4x. So here is our fifth question, derivative of x square into 2x plus 3. We can solve this question by two methods. Look at method 1. That is, we can multiply x square with 2x plus 3 and we'll get the answer as 2x cube plus 3x square. Then we can differentiate each of the terms and we can obtain the answer as 6x square plus 6x. We can do this by another method, product rule. That is d by dx of u into v. We know the answer. The derivative is u v dash plus v u dash. To do this, we need to obtain u, v, u dash and v dash. Here u represents the first function x square. U dash represents derivative of first function, that is 2x. V is 2x plus 3 and v dash is derivative of 2x plus 3, that is 2. Now we can apply, that is u v dash. U is x square and v dash is 2 plus v u dash. V is 2x plus 3 and u dash is 2x. On solving, again we will get the same answer, 6x square plus 6x. So here is our sixth question, derivative of cos root x. This is also a trigonometric functions. In case of cos x, the derivative is minus sin x. So here we can write it as minus sin root x into derivative of root x. Now we will find derivative of root x. We can write root x as x raised to 1 by 2. Now this is in the format x raised to n. We know derivative of x raised to n, that is equal to n x raised to n minus 1. We can apply this in x raised to 1 by 2. We will get the answer as 1 by 2 into x raised to 1 by 2 minus 1. On solving, 1 by 2 into x raised to minus 1 by 2. Or we can rewrite it as 1 by 2 into 1 by x raised to 1 by 2. Again, x raised to 1 by 2 is root x. So the answer is 1 by 2 root x. So coming back to the first section, derivative of cos root x is minus sin root x into derivative of root x, that is simply 1 by 2 root x. So the answer is minus 1 by 2 root x into sin root x. Look at the seventh question, d by dx of ax square plus bx plus d. Differentiate each of the terms and we'll get the answer as 2ax plus b. Now look at eighth question, d by dx of tan ax plus b. That is simply sec square ax plus b into derivative of ax plus b, that is a. The answer is a into sec square ax plus b. Now the ninth question, d by dx of cos tan x minus sin tan x into derivative of tan x sec square x. Answer is again minus sin tan x into sec square x. Now the last one, question number 10. Derivative of x raised to 6 plus 7x raised to 8 plus 121. Differentiate each of the terms and we will get the answer as 6x raised to 5 plus 56x raised to 7. Please look at the next question. Find d by dx of sec tan root x. This is a bit advanced level question. Here we need to apply chain rule twice. So first of all, starting from sec, that is sec tan root x, tan root x. Now we need to multiply it with derivative of tan root x. Again, derivative of tan root x is sec square root x into derivative of root x, that is 1 by 2 root x. So the answer is 1 by 2 root x into sec square root x into sec tan root x, tan root x. So here is our next question, d by dx of cos x cube into sin square x raised to 5. In this case, we need to apply product rule. D by dx of u into v is u v dash plus v u dash. So first of all, we need to identify u and v. Then we need to find out u dash and v dash. U is the first function cos x cube and v is the second function sin square x raised to 5. Now u dash, derivative of cos x cube, that is minus sin x cube into derivative of 3x square, that is minus 3x square into sin x cube. Now v is equal to sine square x raised to 5, or we can rewrite it as sine x raised to 5 the whole square. Now we need to find out v dash. V dash is 2 into sine x raised to 5 the whole raised to 1 into derivative of sine x raised to 5, that is cos x raised to 5 into 5x raised to 4. So the answer is 10x raised to 4 into sine x raised to 5 into cos x raised to 5. Now we can apply u, v, u dash and v dash in the question. So the answer is cos x cube into 10x raised to 4 into sine x raised to 5 into cos x raised to 5 plus sine square x raised to 5 into minus 3x square sine x cube. So the final answer we can obtain as 10x raised to 4 into cos x cube sine x raised to 5 into cos x raised to 5 minus 3x square sine x cube into sine square x raised to 5. So here is our last question. D by dx of sine ax plus b divided by cos cx plus d. As in the previous case, we need to identify u and v, and we need to find out u dash and v dash. Here u is sine ax plus b, and we can obtain u dash as a into cos ax plus b. Now v is equal to cos cx plus d and v dash is minus c sine cx plus d. So we can apply in the formula. We'll get cos cx plus d into a cos ax plus b minus sine ax plus b into minus c sine cx plus d the whole divided by cos cx plus d the whole square. On solving, we can obtain the final answer as a cos ax plus b into cos cx plus d plus c sine ax plus b into sine cx plus d the whole divided by cos square cx plus d. So that's all about chain rule and exercise number 5.2. In the next video, we'll learn implicit functions. Thank you.